Welcome for this lecture. In the previous lecture, we have seen root locus concept. In that we have seen basically the transfer function we require or we are using in the pole 0 form. So, if it is in the time constant form, you have to convert it to pole 0 form and then we have to use it. So, the first thing is which we have seen is the angle criterion. So, a plot of the points in the complex plane satisfying the angle criterion is the root locus. So, what is angle criterion? If we are considering GSHS as a polynomial of S, PS, then angle of PS is equal to plus minus 180 degrees into 2q plus 1, where q is 0, 1 and so on. So, how many branches are there, accordingly we will get. So, this is angle criteria. Every point on the root locus should satisfy this angle criterion. So, this is the first thing. Second is the magnitude criterion. The value of gain corresponding to a root can be determined from the magnitude criterion. So, what is the magnitude criterion? Absolute value of PS is equal to 1. So, this thing we have seen last time. Now, today we will see construction rules. So, how to draw approximate root locus, that we will see. So, what are the construction rules? Particularly they are represented to get the approximate graphical solution or graphical plot. So, the first rule, the root locus is symmetrical about the real axis. So, what is meaning of this? We have seen that the S plane we can represent it real axis as sigma, imaginary axis as j omega. Where the roots will lie? Either the roots are on real axis or they are complex conjugate or on imaginary axis. So, what is the meaning of this? We will get always the roots are symmetrical or root locus is symmetrical about the real axis. This is the real axis. So, if it is on the real axis, no problem. Symmetrical means because the complex conjugate roots are there, it is symmetrical about the real axis. So, always the root locus is symmetrical about the real axis. So, this is the first thing. Second thing is, as k increases from 0 to infinity, each branch of the root locus originates from an open loop pole with k is equal to 0 and terminates either on an open loop 0 or on infinity with k is equal to infinity. See, we are considering here the parameter is changing, the system gain which we are considering as k, and it is varying from 0 to infinity. So, when k is 0, the root locus will start from open loop poles. So, this rule says that it starts from open loop poles. As k tends to infinity, it reaches to the 0 or it goes to the infinity. So, I will try to explain meaning of this. So, what we have seen, the 1 plus GSHS is equal to 0. GSHS is the polynomial function. That polynomial function we can represent as k as the system gain. It is product of I is varying from 1 to m s plus zi, that is number of zeros, upon product of j is varying from 1 to n s plus pj, that is the number of poles. So, here number of zeros are m, number of poles are n. For a feasible system, for a realizable system, we know very well that m should be less than n. At the most it is equal to n. So, this 1 plus GSHS is equal to 0. This is the thing which we have seen. Now, try to simplify it. So, what we will get here, is product of j is varying from 1 to n s plus p j plus k into product of I is varying from 1 to m s plus z I is equal to 0. Denominator you will get as s plus p j, but as it is 0, numerator will be 0. Consider first k is 0. So, when k is 0, this term vanishes because k is 0. So, what is remaining? Only the poles, open loop poles. So, in the rule it is considered that as k increases from 0 to infinity, each branch of the root locus originates from an open loop pole with k is equal to 0. That you can understand from this. If k is 0, this term vanishes. So, what is remaining? Only the open loop poles. So, branches will start with open loop poles. Next is it terminates either on an open loop 0 or on infinity with k is equal to infinity. So, we will consider if k tends to infinity, what will happen. So, the same thing we can write as 1 upon k product of j is varying from 1 to n s plus p j plus product of I is varying from 1 to m s plus z I is equal to 0. Now, k tends to infinity. So, k tends to infinity means 1 upon k tends to 0. So, what we will get? This term will vanish. As this term will vanish, what is remaining? Only zeros. So, branch will terminate at 0 when k tends to infinity. So, the rule says that when k is 0, branches will start at open loop poles. When k tends to infinity, branches will terminate at open loop zeros. But one thing we have seen that the n are the open loop poles, so n are the open loop poles, m are the open loop zeros, and we have seen here that m is less than n. So, there are n branches. Out of n branches, n minus m branches will terminate to the zeros. What about remaining? So, remaining will terminate or will go towards infinity. So, this rule says that the number of branches terminating on infinity equals the number of open loop poles minus zeros. So, open loop poles minus zeros means we will get n minus m branches will terminate towards infinity. So, I think the second rule is clear. K is varying from 0 to infinity. When k is 0, this term will vanish, only this term is there. So, it will start from the open loop poles. When k tends to infinity, this term will vanish. So, only zeros are there. So, branches will terminate at zeros. So, how many branches will terminate? M branches, but n is greater than m, and so there are n minus m branches will remain, and those will terminate or will go towards the infinity. So, the second rule says that. Third rule, a point on the real axis lies on the locus if the number of open loop poles plus zeros on the real axis to the right of this point is odd. Okay. So, now I will try to explain this term particularly. So, we will consider some open loop poles and some open loop zeros on the S plane. Okay. So, we will consider some open loop poles and zeros. Suppose one pole is at origin, one pole is here and third pole is here. So, we will write here it is P1, P2 and P3, while 1 0 is here. So, I will write here as Z1, open loop 0 is here and 1 0 is somewhere here. So, 2 zeros are there. We can consider some complex conjugate poles also. So, suppose I am considering complex conjugate pole like this, then I will write this as P4 and P5. So, what is the thing you will get? 5 poles and 2 zeros. Now, what the rule says? Rule says that a point on the real axis, meaning is that I want to find out whether this point on the real axis is on the root locus, that I want to check it. So, how will you consider this? We have to apply the angle criteria. If the angle criteria is satisfied, then the point is on the root locus. So, what is angle? If I am considering this as S0, what is angle made by this pole P1? We can see that we will get 180 degrees. What is angle made by P2? We can see this is 180 degrees. What is angle made by 0? This is 180 degrees. What is angle made by Z2? It is 0. Consider this point S0 is the point which we want a trial point, whether it is on a real axis or not. If I am considering P3, what is angle made with S0? It is 0. So, we are considering only right side of this point, we are not considering on the left side of this point. That is the first thing. So, see the rule, a point on the real axis lies on the locus if the number of open loop poles plus zeros on the real axis to the right of this point is odd. So, consider this now. How many poles are there? 2 poles are there, 1 0 is there. So, 2 plus 1, that is 3, 3 is odd, then this point is lying on the root locus. Why? Because see the angle made by this is 180, angle made by this 180. So, 0 minus pole if we are considering, so it will get cancelled, this will be 180. So, what is your angle criteria? Angle criteria is that we want plus minus 180 degrees. So, we will get here 180 degrees. Suppose it is even, what will happen? Suppose we are considering one more 0 here, then what will happen? This is 180 plus 180, 360, this is 180 plus 180, 360, you will get 0 angle. So, it will not satisfy this particular criteria, and so you want odd number of poles and zeros. If it is even, that point is not lying on the root locus. There is no point to be considered to the left side of this, because angle made by Z2 and P3 are 0. So, instead of considering the complex poles, suppose we will consider complex poles here, complex conjugate poles. Then what is angle made with S0? You can see this angle we will get, okay. And so, what we will get? Now, you can measure how many are there, 2 plus 2, 4 plus 1, 5. So, it is odd. So, this point is lying on the right side of on the root locus. S0 is lying on the root locus. Why? Because angle made by this will get cancelled and total you will get it as 180 or multiple of 180. So, multiple of 180 means we are writing it, the actual formula is where Q is 0, 1 and so on. Is it okay? And so that I think now the rule 3 is clear, a point on the real axis. So, suppose I am considering instead of this point, whether this point is on the real axis or not. This point on the real axis is on the root locus or not. So, what you will get? 1 0, 1 pole. So, 2 even number you will get. So, this will not lie on the root locus. Why? Because this is 180, this is 180, this is due to 0, this is due to pole, so it will get cancelled and angle will be 0. So, this is not satisfied. So, if it is even, it will not satisfy the angle criteria and so the point will not lie on the root locus. So, only to the right side of this point you have to consider. So, this is the rule 3. So, to understand perfectly, we will see one example. So, consider a unity feedback system with open loop transfer function Gs is equal to. So, I will represent here and then you represent open loop poles and zeros where they will lie. So, first I will draw the system diagram or the block diagram. So, what we will get? Open loop transfer function. So, what is the open loop transfer function? Given it is k into bracket s plus 1 into s plus 2 upon s into bracket s plus 3 s plus 4 and a unity feedback system. This is negative feedback, plus minus, this is input, this is output. So, a system is given by this way. Now, what is problem? Consider the unity feedback system with open loop transfer function G s is equal to this. So, where are the zeros and poles lying? So, we will write first that open loop zeros. So, where are the open loop zeros? One is at minus 1 and one is at minus 2. Open loop poles, one is at 0. So, P 1 is at 0, P 2 is at minus 3 and P 3 is at minus 4. S is 0, S is minus 3, S is minus 4. Here S is minus 1, S is minus 2. So, how many, the notation which we are using for the open loop poles is N and for open loop zeros it is M. So, how many zeros are there? 2 zeros are there. So, M is 2, N is 3. That information we will get from this transfer function. Now, what we want to see, whether or how we will consider the which part of the root locus, real part will lie on the root locus. So, draw these open loop poles and zeros on S plane. So, draw S plane. This is real axis, this is imaginary axis. First we will draw zeros. So, this is minus 1, minus 2, minus 3, minus 4. Zeros are at minus 1. So, how to represent 0? A small circle. Z is equal to minus 2. So, a small circle. Then P 1 is at 0. So, one pole is represented by a cross. So, P 1 is 0, P 2 is minus 3 and P 3 is at minus 4. Now, we will see which part of the real axis will lie on the root locus by considering the rule number 3 particularly. Okay. So, consider now 0 to minus 1. Okay. So, when we are considering 0 to minus 1, any point in between. So, this is 0. So, consider I am considering this is the test point. How many poles and zeros to the right side of this? 1. So, it is odd, meaning is that this will lie on the root locus. So, from minus 1 to 0, it will lie on the root locus because only one pole is there. Consider a point in between minus 2 to minus 1. Then how many to the right side of this? 1 0 and 1 pole. So, it is even. So, this will not lie on the root locus, that is minus 1 to minus 2, that real axis part will not lie on the root locus. Consider a point between minus 2 and minus 3, then what we will get? 2 zeros, 1 pole. So, total is 3. So, it is odd. So, it will lie on the root locus. So, how will you get it, or you can represent minus 3 to minus 2, this will lie on the root locus. Consider point between minus 3 to minus 4. Again now you can see 2 zeros are there, two poles are there. So, this will not lie on the root locus. Consider the point after minus 4 somewhere here, whether it will lie on the root locus 1, 2, 3, 4, 5. So, it is odd. So, it will lie, meaning is that this will lie on the root locus. Now, what is the rule 2 says? It starts with the open loop poles, that is this branch will start from 0 and from P1 is equal to 0 and terminates at minus 1. Here the branch will start from open loop pole, that is from minus 3 and will terminate at 0. So, here 3 poles are there, 2 zeros are there. So, n minus m is 1, that is one branch will go towards infinity. So, if the branch will start from open loop pole and will go towards infinity. So, we will get it in this way. So, which part of the real axis will lie on the root locus? Minus 1 to 0, minus 3 to minus 2 and minus 4 to infinity. This will lie on the root locus. It will originate from the pole and will terminate at 0. So, we can draw it in this way. So, I think all the rules are clear. So, first rule is just it is symmetrical about the real axis. Second is it will start from open loop poles, terminate at zeros and n minus m branches will terminate towards or will go towards infinity. And the third is which part of the real axis will lie on the root locus, that we have seen with this example particularly. Next we will see next rule. So, rule number 4. So, by applying all the rules, we can draw the root locus properly. So, now we will consider rule number 4. So, rule number 4 is the n minus m branches of the root locus which tend to infinity do so along straight line asymptotes whose angles are given by. So, it is now clear that n minus m branches will go towards infinity. Then how it is going towards infinity? So, some asymptote is required and the angle is given as phi a is equal to 2q plus 1 into 180 degrees upon n minus m, where q is 0, 1. How many branches are there? N minus m branches are there. So, q will be started with 0. So, what will be the last value? Last value will be n minus m minus 1. So, total n minus m branches will be there. So, q value is this. So, from here we got this particular formula that we can see when we are considering the branch is going towards infinity. So, from infinity, if we are considering the phasor which is connected to the open loop pole and zeros, it gives us nearly the same angle. So, that angle we can consider like this. So, the angle GSHS is equal to minus n minus m into phi. So, phi is a angle. See that it from infinity we are considering open loop poles, a phasor diagram or a phasor. So, we are considering from remote place nearly the same angle we will get, and so we can write it in this way, and then we will get the formula is minus n minus m phi should satisfy the angle criteria. So, what is the angle criteria? Plus minus 180 degrees into 2q plus 1. Okay. And from this we can derive the formula. or we will get this particular formula. So, it should satisfy the angle criteria, and for that it is given in this way. Next is rule number 5. The asymptotes cross the real axis at a point known as centroid determined by the relationship. Okay. So, what is the relationship? It is given in words: sum of real parts of poles minus sum of real parts of zeros upon the number of poles minus number of zeros. So, mathematically we can write it as, so centroid is given as sigma. So, minus sigma A is equal to summation of real parts of poles. So, we will get it as Pj, j is varying from 1 to n, okay, minus summation of real parts of zeros. So, minus zi, I is varying from 1 to m upon n minus m. So, mathematically we can represent the formula is like this. So, we will get here centroid. So, what is the centroid? The asymptotes cross the real axis, that point is called as the centroid, and the formula we will get it in this way. So, we will try to draw the complete root locus by whatever the rules we have seen, that is total 5 rules which we have seen, we will try to draw the root locus. So, consider this example. So, the example is 1 plus k upon s into bracket s plus 1 s plus 2 which is equal to 0. Consider a feedback system with characteristic equation is like this. So, we will try to solve it step by step. Okay. So, while solving the root locus, you write all the steps properly sequentially. So, the first step is, write down here open loop zeros and poles. So, no 0, no open loop 0 and open loop poles are first pole is at 0, second pole is at -1 and third pole is at -2. So, in the second point we can write what is the value for n? N is 3. How many open loop poles are there? 3. How many zeros are there? M is equal to 0. So, we will get value for n and m by considering open loop poles and zeros. So, what we will get the information by applying the rule number 2. So, we will go back again for the rule number 2 and we can consider it. So, I think there is no necessity to consider rule number 1 because root locus is symmetrical about the real axis. So, what is rule 2? As k increases from 0 to infinity, each branch of the root locus originates from the open loop pole. So, we will try to draw the root locus now. First step is you can write, describe here, then you can draw, both ways you can do. So, we can write here how many branches will be there as per this rule. So, when k is 0, the root locus originates from an open loop pole. So, how many branches will be there? 3 open loop poles are there. So, there will be 3 branches. Okay. So, there will be 3 branches of the root locus, 3 branches of the root locus originates from P1 is equal to 0, P2 is equal to minus 1 and P3 is equal to minus 2. Okay. So, parallelly we will represent on the root locus. So, this is the S plane, real axis sigma. So, whenever we are drawing S plane, the basic thing is you have to write what is your x axis, what is y axis. So, real axis is sigma, imaginary axis is j omega. Represent now open loop poles and zeros. There are no zeros, so no problem. Represent the poles. So, consider this as minus 1, minus 2, minus 3. This is 0. So, one pole is at 0, another pole is at minus 1 and next is at minus 2. So, represent the 3 poles. 3 branches of the root locus originate from these 3 poles. So, that information we will get at k is equal to 0. This will originate at k is equal to 0. Next, we will apply which part of the real axis will lie on the root locus. So, apply the rule 3. So, how will you consider? By applying root 3. See, consider between 0 and minus 1, whether this will lie on the root locus. It will not lie on the root locus. Why? Because only one pole is, it will lie on the root locus because one pole is there. So, it is odd. So, we will get this will lie on the root locus. Minus 1 to minus 2, whether it will lie on the root locus? No, because 2 poles are there. Minus 2 to minus 3, whether it will lie on the root locus? Yes, because 3 poles to the right side of that. So, you will get here and so it will go all the points we will get, because any point if you are considering 3 poles are there which is to the right side, which is odd, and that is why all the points we will get. So, applying the rule 3, we will get 0 to minus 1 will lie on the root locus and minus 2 to infinity will lie on the root locus. Minus 1 to minus 2 will not lie on the root locus. Okay. Next is rule 4, n minus m branches of the root locus will tend towards infinity. So, here n is 3, m is 0. So, all the 3 branches will go towards infinity. Now, we have to find out at what angle they are going along the asymptotes, whose angles are given by. So, fourth step is 3 branches will go towards infinity. Infinity through asymptotes. With the angles phi a is equal to. So, what is the formula for phi a? 2q plus 1 into 180 degrees upon n minus m, where q is 0, 1, n minus m minus 1, n minus m is 3, 3 minus 1, that is 2. So, we will get q is 0, 1, 2. So, what is the first angle we will get? So, that we will write. So, in the step 4, we are considering first phi a will be, q is 0. So, what is the value you will get? 180 upon 3, that is equal to 60 degrees. Second angle will be, now consider q is 1. So, 3 into 180 upon 3. So, it is 180 degrees, and with q is equal to 2, we will get 5 into 180. So, this is if you want you can write here, this is with q is equal to 0, this is with q is equal to 1 and 5 into 180 degrees upon 3. So, you will get 300 with q is equal to 2. So, applying the rule 4, you will get the angles are 60, 180 and 300. Okay. So, just we are applying all the rules to this particular example. Next rule is find out centroid. So, how to find out centroid for this particular example? So, step number 5. Centroid. So, minus sigma A is equal to, what is the formula we have seen? The formula we have seen is that summation of real parts of poles minus summation of real parts of zeros upon n minus m. Summation of real parts of poles. So, what is real parts of the poles? One pole is at 0, second is at minus 1, third is at minus 2. So, summation we will get is minus 1 minus 2 upon n minus m. So, n minus m is 3. So, you will get this is minus 1. So, you will get a point which is called as centroid is equal to or it which is at minus 1. So, this is your centroid. Okay. Now, the segments of the real axis which we have seen, now we will see how the asymptote will go. Okay. So, the angles you got it as the 60 degree. So, from minus 1 point which is the centroid, you have to draw asymptote at 60 degrees. So, how will you draw that? See, this is your centroid, angle you have to measure from anti-clockwise with this axis. So, draw the asymptote and this angle is 60 degrees. Second asymptote is at 180 degrees, that is the axis which we will get, and the third asymptote is at 300 or minus 60 degrees. So, you will get this is 300 degrees. So, how will you represent 300 degrees? And this is the second one. Okay. So, you got the asymptotes like this. So, 60 degree, 180 degrees. So, I think I will represent 180 degrees and this is 300 degrees. Now, one branch we can directly draw that it will originate from minus 2 and will terminate towards infinity or it will go towards infinity. So, the root locus branch we will get or we can represent it is like this. Okay. So, the thing which we are considering here is that along with this asymptote, one branch will start from this pole, one branch will start from this pole, they will meet somewhere here because this part of the real axis is on the root locus and they will break away from this point and will follow this asymptote and second will follow this asymptote. So, the branches you will get it in this way and so we can represent it particularly in this way. Okay. So, see again, go back and check that all the rules we are applying whatever we have seen till now, till this point.